So good morning, everyone. My name is Burkhard Militzer. I'm professor at UC Berkeley, and I'd like to welcome you all to this year's summer school on quantum Monte Carlo. And we will have 5 days of computational methods, lectures in the morning usually, and labs in the afternoon. And we have almost 50 participants from around the world. Some have traveled far away, I guess. Some are probably still on jet lag. And I remember that feeling because David Zeppeli, who will introduce himself in a second probably, has a tradition of organizing such summer schools. And 12 years ago, I came from Germany, arrived jet-lagged, and that was my first impression of this country. And I can assure you the weather was about the same. So I hope you take away all these things we tell you, and I'm sure they will be, to some of you, will be useful, and they were certainly very useful to me, and I was totally clueless when I arrived here. So hopefully that changed a little bit. So I have a few things I would like to say. In particular, the lecturers should stand up and say hello. So that's David Zeppeli. I think you should clap after, actually. We have actually done something. Then there's Ron Cohen, our first lecturer from the Carnegie Institution of Washington. He's an expert in quantum Monte Carlo and applications to high-pressure physics, in particular for geophysical application in the interior of the Earth. So ask him about FEO. FEO is a material where DFT doesn't work very well. So Jongnim Kim from Oak Ridge National Lab. She maintains the QMC pack code that we will be using on Wednesday, I believe. So if you want to run a ground state quantum Monte Carlo code, that's one of the best ones, most efficient ones available at the moment. Luke Schulenberger, who is not here yet because he was one of the less fortunate ones when it comes to airplane connections, will join us a little bit later. Eric Distel is a mathematician from Virginia Polytechnic Institute and State University, and he is an expert on mathematical methods when it comes to evaluating determinants in the Krylov space and other ways very efficiently. So just to explain, the summer school is funded by the National Science Foundation as a collaboration between geophysics and mathematics. So Eric is our mathematical representative on the team and makes sure that we are expanding quantum Monte Carlo to larger and larger systems while we're using optimal mathematical routines to make this possible. So we have 2 lab instructors. There's Kevin Driver, who is in the back from UC Berkeley. He works with me as a postdoc and divides his time in quantum Monte Carlo and recently also path integral Monte Carlo. And you will hear about it tomorrow afternoon when you'll be running path integral calculations on carbon plasmas. And there's Jeremy McNinnis, who is a postdoc here with David Zeppeli. Is Jeremy around? Well, we will see, meet him during his lab. And also we have 2 committee members, Nehil Naab and Umberto Ravaioli. They may not be here in the room, but they joined the organizing team and they helped us to get access to the facilities here in this wonderful Beckman Institute. The summer school is basically being funded mainly by the National Science Foundation. We also got support from Oak Ridge National Lab and Dell Computers, who provided some of the laptops. And it's been co-sponsored others here at the Materials Computation Center at the Beckman Institute for Advanced Science and Technology, the Fritz Reitz Materials Research Center, the National Center for Supercomputing Applications, and the Network for Computational Nanotechnology. So, as I said already, we have a reasonably busy schedule, but not really, actually, for the week. In general, we have lectures in the morning, and we have an extended computer lab in the afternoon. And the goal is really that you get your hands on these codes and run these exercises yourself. We cannot do this for you. Learning this yourself is the first step of actually getting some of these unfamiliar computational tools to work. So this is an integral part of the school. It may be much more useful of making your own mistakes in those labs and actually listening to us, telling you how things should work in principle. So the slides from our presentations in the morning will be posted on the schedule on the website, and they'll be linked. And also we are currently being video recorded, which probably means all lecturers will repeat the questions that you will be asking without a microphone. So anything you say will be recorded for all eternity. And we have a few things about the schedule we should tell you about. First of all, besides lectures and computer labs, we have a picnic this afternoon. There's plenty of food, so basically starve for the better part of this day. And Amy tells me it's really 101 Fahrenheit. We will have the picnic inside from 6 to 8. We have a poster session from on Wednesday from 3:30 to 5:30. And posters are basically a way to get to know each other. We want to know what you do, and you should know about the other participants. And one of the better ways actually have posters. We got plenty of questions while I'm not really doing quantum Monte Carlo yet. How shall I present a poster on quantum Monte Carlo? So the goal is not really that you present on quantum Monte Carlo, but to give an introduction to your own research, that we'll know what you do, and maybe then arises the possibility of doing some aspect of your research with these techniques that we teach you here for this week. On Thursday night, from 6 to 8, we have a banquet where we're all going to see each other. And on Friday afternoon, we have two things. In the later part, we have a tour of the Blue Waters computer, which will be one of the biggest computer being built. It's a petascale machine, and Illinois was very fortunate and successful in getting this gigantic machine here on campus, which is important for, I think it's important for NCSA and others to actually continue the tradition on having a world-class supercomputer here. And when this petascale machine was awarded to come here to Illinois, it was a big event. And now we sort of, you can get a tour because you're here. And maybe eventually we could actually be using one of those machines, because David is making sure that at least one quantum Monte Carlo code will be running on this, I hope. That's the goal. So the argument is basically when you run on maybe 100 cores now, with the computer, you find this, oh, this is quite a bit, but they give you 100,000 cores and they ask you, can you use them? It's not whether how you scale for a factor of 10. It's basically we throw so many processes on the problem, you have to rewrite your algorithm from scratch. However, before we do that, we have a problem-solving session. And where we are, the instructors of the school are here for your disposal, and we help you with your own problems. Preferably, if they should be related to the school. And, but in general, I would like to advertise this. David Zeppelin and others going to solve your PhD problems. This is not quite true, but you should take the advantage of asking someone else who is maybe not be familiar with your technique or with your problem, what would you do? And you may get a useful answer, may also get a totally lousy answer. So in this case, don't blame it on us, but you actually get some comments. So we may have this one-on-one discussions, or we can actually go back and have another discussion on some of the codes. So if you want to use one of those ground state quantum Monte Carlo codes, we may have a session for this, where people get together, or we may have a session on path annuals if you're interested. So we are not quite sure how we organize it, but we're basically waiting for your feedback. So there is 2 hours for you to ask questions. We have not quite decided on the format yet. So do you have any short questions that may be of general interest? Otherwise, I would say welcome. I hope you have a good week.